In this presentation, we will learn how to count the number of elements in a circular singly linked list. So let's get started. Let us suppose we already have this list and our task is to count the number of elements of this list. How many nodes are there in this list? In other words, right? Here you can see tail pointer is currently pointing to the last node of this list. We have to traverse the list in order to count the number of elements in the list, obviously. For this, we will keep a temporary pointer. That means I'll keep a temp pointer which must point to the first node of this list. After this, we will also keep a variable named count for storing the count of the elements in the list. So this is the count variable, and here you can see I have declared this count variable, and you can see over here it is initialized to 0, right? Now we are ready to traverse the list. For this purpose, we will use this while loop and we will put this condition. If temp is not equal to tail, then increment the count by 1 and move the temp pointer towards right. That's it. If temp is not equal to tail, this condition is important. When temp becomes tail, this means we have reached the last node of this list. Then we should stop. Okay? So let's just evaluate this piece of code. We know that temp is currently not equal to tail. So we'll get inside, we'll increment the count by 1. That means we have reached the first node of this list. Now, we will move our temp pointer towards right so that it can point to the second node of this list. Then again we will check this condition. Is temp equal to tail? No. Currently it is not equal to tail. Thus we will increment the count by 1. Now it will get incremented, so it becomes 2. Now we will move our temp pointer towards right so that it can point to the third node of this list. Then we will check this condition once again. If temp is equal to tail? No. We'll get inside, increment the count by 1. And then we'll move our temp pointer towards right so that it can point to the last node of this list. Now you can see that temp is equal to tail, right? So this condition becomes false. This means we'll get outside of this while loop. But you can see that here count is equal to 3. But you know that we have reached the last node of this list, right? That is why it is important to put this line of code after while loop, that is count plus plus. We must have to increment our count after the while loop finishes its execution. Okay? The time complexity of this code is order of n because we have to traverse the complete list. Now let me just show the complete code in code blocks. Here you can see I have declared struct node, then we have add to empty function, add at end function, then we have this count elements function. Okay? This is used to count the number of elements. Here we just have to pass the tail pointer. And the whole procedure is similar to what we have seen. After count plus plus, one additional line is added, that is the call to the printf function. Here to this printf function, we are passing this message. There are %d elements in the list. %d will get replaced by the count because I want to print the count of the elements after the completion of this code, right? Here in this main function, tail pointer is declared. Add to empty function is called in order to create the first node of the list. Add at end functions are called thrice. Here, first time 45 is passed, then 66 and then 6. Finally, count elements function is called in order to count the number of elements. Let me just execute this code. You can see that the output of this program is there are 4 elements in the list. We know that there are 4 elements, right? The first element is 34, the second element is 45, third element is 66 and fourth element is 6. That is why there are 4 elements in the list, right? Okay friends, this is it for now. Thank you for watching this presentation.